Okay, so we're going to go over 3.3, right? And then ready for more. And so we've been comparing adding, subtracting, multiplying, and dividing polynomials to numbers, but here is the reason in which why they're not the same, meaning not analogous. Like I can't use these two in the same way that I did previous. And so let's see if it makes sense. So let me start with this one. When we're adding these together, we're just collecting like terms. So we're adding 7x squared plus 4x squared. How many x squareds is that? Yeah, 11x squared. It's very good. And then I'm going to add 3x's plus 2x's. How much is that? Very good. 7x's. And then last but not least, what's 2 plus 1? You guys are like, okay, 3. So Ms. Johnson, what's the big deal? So 11x squared plus 7x plus 3 is not analogous to this one because of what happens. Okay, so let's put 421 right under here. So when I add it, I get 3. Oh, did I add the wrong numbers? Oh my gosh, you guys, I don't know how to add. It's 5x. Sorry. 3x plus 2x is 5x. Did you get? Yes, thank you for getting that. I appreciate it. Okay, so 3 and then 3 plus 2 is 5, which what I just got. And 7 plus 4 is 11. And you guys are like, Ms. Johnson, it is the same. Look, 11, 11, 5, 5, 3, 3. Kind of. Because what we were saying here was each term was its own place value, right? But here, this is an x squared. Its place value would be x squared. And according to this, I don't know why that other one isn't showing up, but I'm waiting for it. There it goes. It would be 1x squared. And because you have that 1 pushed over, this would have been 1x cubed. So do you see how they're not perfectly analogous? It's not perfect, but it's a good enough start for you to understand. So it's a very subtle difference. And the biggest thing, I would have shown you a little bit of a different way to do this. I would have changed maybe this 1 to a 9. So it will make more sense if you add these two together. So can you add these two together? 7x squared plus 3x plus 2, and then 4x squared plus 2x plus 9. So when you add these two together, right, you get 11 plus 5x, and then 11x squared. You guys all see that? But when I add those two numbers together, right, when I get 732 plus 429, do you see what would happen here? Do you guys remember what that language was right here? What's 2 plus 9? And you guys would say, it's 11, Ms. Johnson. And I'm like, yeah, but how do you write it? And do you guys remember what you would do? What would you do here? Yes, very good. You guys remember this. This is like way back in the day, right? In second grade, where you have to carry the 1. Very good. And the reason why we're carrying the 1 is because we filled up the 10's place value, and we need to carry that. It's not really a 1, it's actually a 10 to the top and put it in the 1's column. Okay. And then if you did that, that would be 6. And if you did that, that would be 11. Do you see how this doesn't match this? That's why it's not analogous to it. Does that make sense? Because here, these two numbers, when I added them together, when we did the carrying, like you guys talked about, it actually moves one of the values of the 10 here to the next place over. And here we don't do that. You can have this number be gigantic. You'll never carry it over to the x terms because these are not like terms. Does that make sense? All right. Hope that makes sense.